Graphs of radical functions. So let's start with the basic radical function, which is y is equal to square root x. Since the square root of a blank number, well, what doesn't exist? A negative number does not exist. In the real number system, the domain of y equals root x is x, well, here let's be formal. The set of all x such that x is greater than or equal to 0. For y equals root x, complete the table of values below, sketch the graph, and complete the following statements. Okay, square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. Let's graph that. 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. This graph is continuous because we can work out the square root of 11 or 12 or sorry, just trying to concentrate and draw. Yeah, well, close enough. The shape of the graph is half of a horizontal parabola. Parabola. With a vertex at 0, 0. So just imagine a parabola going horizontally, and the other half would be down here. The range is r is equal to the set of y, such that y is greater than or equal to 0. Transformations of the basic radical function. All the transformations, including stretches, reflections, and translations that you previously learned can be applied to radical functions. This is the order we do it in: stretches, reflections, and then translations. And in 30-1, there's a lot of this. So use your transformation skills, so let's see if I still have some, to complete the following. Complete the table below by describing the transformation that was made on the graph of y equals root x to produce each function. The graph of y equals root x is shown below. On the same grid, sketch the graph of each function in the table. Ooh, colors. I can use colors. Here, let's switch colors. So the description. So when x is replaced by x minus 2, that is a, oh, nice big bold, horizontal translation 2 units right. So if I want to graph that, I'm going to move stuff over 2 units to the right. So 4, 2, well, it moves 2 units, becomes 6, 2. And 9, 3 becomes 11, 3. And we start here. And we go like this. What do we got? Red. Root x minus 2. The minus 2 is out here. This is a vertical translation, down 2. So now we're going to take each point and move it down 2. So the point that was at 4, 2 will be at 4, 0. 9, 3 moves to 9, 1. 16, 4 moves to 16, 2. And it's not easy doing it on a tablet. 1/2, this is a vertical stretch by a factor of 1/2. So 0, 0, nothing will stretch that. 4, 2 becomes 4, 1. 9, 3 becomes 9, 1 1/2. 16, 4 becomes 16, 2. Oh, best one yet. Y is equal to the negative root of x. This is a reflection in the x-axis. Right. It says take all your y values and turn them negative. Well, it won't do anything to 0. 1, 1 becomes 1, negative 1. 4, 2 becomes 4, negative 2. We'll get 9, negative 3. And 16, negative 4. And now let's see if I can graph this. I should have just pulled out decimals. There we go. And y is equal to, what do we got? Blue. Y is equal to negative 2 root x. So there's two things going on. First, we want to deal with the stretch. So that's a vertical stretch by a factor of 2. Then a reflection in the x-axis. All right, so we take this, we double its y value, and we reflect it, and we stay where we are. The point 1, 1 goes to 1, 2, and then gets reflected. The point 4, 2 becomes 4, 4, and then becomes 4, negative 4 is reflected. So stretch first, then reflected. 9, 3 goes to 9, 6, and then 9, negative 6. 16, 4 will go to 16, 8, and then negative 8. And there we go. Let me go back to the thin black line. So those are all of the, very colorful, isn't it? Wow, rainbow. 4, f of x equals negative 2 root x plus 1 plus 4. State the transformations in the correct order that were made to create the graph of f of x equals blah, blah, blah. Use these transformations to sketch, because I wonder if we were going to draw. Okay, so stretches first. So number 1. There's a vertical stretch by a factor of 2, and that's about the x-axis. Number 2, there's a reflection, so reflected about the x-axis. Number 3, we have a horizontal translation, left 1, and number 4, we have a vertical translation, up 4. So I'm going to go with purple. So basically what we're going to do to sketch this is we're just going to run through all of these. So it's vertically stretched. I'm going to stretch this by a factor of 2. Yep. Reflect it. Yep. Move left 1. Yep. And up 4. So that's where the point 0, 0 has gone. The point 1, 1, vertical stretch by a factor of 2, reflection, left 1, up 4. 9, 3, vertical stretch by a factor of 2 becomes 6, reflected becomes negative 6, left 1, 1, 2, 3, 4, up 4. And 16, 4, you know, well, okay, let's think about it. So it goes to 16, 8 to 16, negative 8, moves left 1 to 15, and then up 4, and it will be at negative 4. And then we draw the graph. Nice, huh? Nice. For fx, the domain. So what's our new domain? So if you look, the stretch and the reflection won't affect the domain, but moving it left 1 does. So the domain is from negative 1, and the range will be less than or equal to 4. So let's write that in. Set of all x such that x is greater than or equal to negative 1. Set of all y such that y is less than or equal to 4. And the understanding is that x and y both belong to the real. The point 25, 5 lies on this graph. Determine its corresponding image point on the graph and verify your answer algebraically. Ooh, need thin black line. All right, so what I'm going to do is I'm going to do these 4, and I pointed with my finger there. That's kind of interesting. So 25, 5, after the first translation, which is vertical stretch by a factor of 2 about the x-axis. So 25, 10, and let's just note that here, VS by 2. Then we reflect 25, negative 10. Reflect in x. we move left 1, HT left 1, and we move up 4, VT up 4. I believe that's it. So if we do f of 25 is negative 2 root 25 plus 1 plus 4. What do we get? Sorry, we want to do 24. Negative 2 root 25 plus 4, negative 10 plus 4 is negative 6. So when we give it a 24, we get out the negative 6. Algebraically determine the x. Oh my god, is there more after this? No. Okay, algebraically determine the x and y intercepts. So, let's do the y-intercept. Y-intercept, we set x equal to 0. So y becomes negative 2 root 0 plus 1 plus 4. So negative 2, root 1 is 1 plus 4. Let's throw that in there, plus 4. Negative 2 plus 4 is 2. So the y-intercept is 2. Can we see that on here? Yes, we can, the y-intercept. And let's do the x-intercept. So to do an x-intercept, we set y equal to 0. So let's write this. Y equals negative 2 root x plus 1 plus 4. 0 is equal to negative 2 root x plus 1 plus 4. Move that over. Negative 4 is equal to negative 2 root x plus 1. Divide both sides. 2 is equal to root x plus 1. Square both sides and reverse at the same time. Oh my god, I've lost. Where are we? Okay. So x plus 1 is equal to 4, and x is equal to 3. So the x-intercept is 3. And, oh wow, look, it even got drawn through there. Great drawing job. And that's not bad, because I thought that, you know, quadratic formula might end up being pulled out or something weird, but it wasn't, and we are done.